Welcome to my case study circle channel. In this video, we shall see how to do the isometric projections of the given combination of solids using the Solid Edge software. In this problem statement, we have a rectangular prism of dimension 60 cross 80 cross 20. That is, the width is 60, the length is 80, and the thickness is 20 mm. And this rectangular prism is surrounding a tetrahedron whose sides shall measure 45 mm. And also there is condition given that the axes of the solids are collinear, and at least one of the edges of both the solids are parallel to VP. So here we need to observe 2 points, that is, with respect to the axis, that is, the axis points of both the solids are collinear, that is, the axis of the tetrahedron and also the axis of the rectangular prism are collinear. So this is the first condition to be considered. The next condition is one of the edges of both the solids are parallel to VP. So one of the edges of both the rectangular prism as well as the tetrahedron shall remain parallel to the VP. So with this condition, we need to construct the isometric projection of the combination of the solids. So the solids here are a rectangular prism and also a tetrahedron. So before we construct the isometric projection, let us construct the orthographic projection of the given combination of the solids. So let us begin by selecting the line option and drawing a line of thickness 0.18 mm marking the XY line. So now we shall construct the top view of the combination of the solids. So select a line of thickness 0.50 mm and then go for the rectangle option. And then let us construct the rectangle by the center point. So the rectangle shall have a dimension of 80 cross 60. So this is the top view of the rectangle. So we need to understand that the thickness will be seen in the front view, and in the top view it is only the top surface of the solid that is visible to us. And also we need to understand the next point, that is one of the edges of both the solids shall remain parallel to the VP. So we can consider that the longer edge of this solid, that is the rectangular prism, is kept parallel to the VP. So go for the smart dimension and just show the dimension of this top view of the rectangular prism. So the outer edges are visible, and that is why we have constructed the same using the line of thickness 0.50 mm. So now let us go for constructing the tetrahedron. So let us just consider the tetrahedron outside and then move it according to the condition. So the tetrahedron is having each side measuring 45 mm. So this is 45, and next 45 again, but the angle shall be equal to 30 degrees. So first let us consider constructing the equilateral triangle of side 45 mm. 45, the edge length is 45, and the angle is 120, followed by 45 and minus 120. So now let us connect the opposite edges to the corners so that we get the triangular faces of the tetrahedron. So go for the trim option and trim the line so that you get a tetrahedron. So this is the tetrahedron whose side is measuring 45 mm. So before we place this tetrahedron here, let us draw the diagonals of this rectangle. So join the opposite corner points. The point of intersection shall mark the origin of the axis of this particular solid, that is the rectangular prism. So now let us consider this tetrahedron and then move this, keeping the point of axis as the reference point. Ensure the copy is off. So just place the tetrahedron in such a way that the axis of the tetrahedron and also the rectangular prism are collinear or coinciding. So this is the condition. So you can just see that one of the edges of the tetrahedron and one of the edges of this rectangular prism are parallel to the VP. So now let us proceed towards constructing the front view of this combination of the solids. So go for the line option. So we have got the projection lines ready from each of the edges and also from the tetrahedron and the rectangular prism axis. So first let us consider drawing the front view of the rectangular prism. So we shall draw the line of length 20 mm marking the thickness of this rectangular prism. So just select this line, change this type to the axis, and then let us go for the line option again. Select a line of thickness 0.50. So complete the base of the rectangular prism followed by the height which is equal to 20 mm and passing through this axis point, and again the length will be equal to 80. So this completes the front view of the rectangular prism. So you can just see that the thickness is 20. So 60 cross 80 cross 20. So this completes the front and the top view of the rectangular prism. So now the same axis shall be considered for constructing the tetrahedron also in the front view. So now let us go for constructing the front view of the tetrahedron. So select a line of thickness 0.13. So from each of the corners of the tetrahedron, just draw the projection lines. Ensure all the lines are exactly 90 degrees. So now you can just see that none of the base edges or the slant edges are parallel to the xy line with respect to the tetrahedron. So what we need to do is we need to consider making one of these edges or the slant edges parallel to the xy line. So just consider the arc by center point and draw an arc, and again consider drawing a line. So from the point of intersection of this arc, let us consider this. So here we need to sweep the line of length 45 mm. So this is the true slant edge of the tetrahedron which is visible to the observer in the front view. So go for the line option and then again select the line of thickness 0.50, and from this edge join this. Then again let us go for considering the extend to next option and just extend the axis line. So now let us go for distance between. So this point of intersection, so select this point and this point. So 36.74 is the actual height of the tetrahedron in the front view. This is 20, so the height is 36.74. So we have considered by drawing the slant edge which is measuring 45 mm. So this is 45 mm. So this completes the construction of the orthographic projection, the combination of the solids. So let us go for annotation and annotate the reference line as X and then Y, and also the planes as VP and HP. So this completes the procedure to construct the front view and the top view of the combination of the solids. So now it is time for us to draft the isometric projection. So go for the line option, select a line of thickness 0.13 and draw a line of any arbitrary length. So now we need to construct this particular rectangle. So either you can start with considering 60 mm or 80 mm, anything is fine. So we'll just consider from this point, draw a line of length 60 mm inclined at an angle of 30 degrees. So that means in your isometric sheet you'll be joining 6 boxes followed by 8 boxes inclined at an angle of 150, again 60, angle is minus 150, and then complete the rectangle. So 80 and minus 30 are the angles. So this is the first step. So now let us draw the height of the prism. So 20 mm followed by 60, again angle is 30, again the length is 80, the angle will be equal to 150. So in this way we can complete the construction of the rectangular prism. So the length is again 60 and the angle is minus 150. So this completes the construction of the isometric view of the rectangular prism. 60, 80 and 20. So now we have to consider drawing the tetrahedron. So first, before we start, let us join the diagonals of this rectangular prism so that we get the point of axis. And now let us go for considering the construction of this tetrahedron. So the tetrahedron is nothing but a triangle in the top view. So let me select a line of thickness 0.13 and select a blue color line and enclose this triangle within the rectangle so that I get to draw this rectangle and then mark the points. So now what I can do is I can construct this rectangle on the surface of the rectangular prism and then mark these points, say 1, 2 and 3, and then complete the construction of the tetrahedron. And from this point of intersection, that is, take the axis which is equal to 36.74 and then complete the projections. So now let us begin the procedure. So let us start drafting this particular rectangle. So before we start constructing this rectangle, we do not know the distance. So just go for the smart dimension or the distance between option. Select this. So this is the difference and go for the distance between and measure this rectangle dimension also. 45 and this is somewhere around 38.97. So you can just approximate that to 39. So nearly approximately 4 boxes in the isometric scale. So go for the line option. So using the same color, let me start constructing the rectangle. So from this midpoint, let me draw a line of length 17.01 at an angle of 30 degrees. So nearly 1.7 boxes in the isometric sheet. So from this point, I have to start constructing the distance of the length of the rectangle. So that is midpoint, if I consider 22.5 at an angle of 150, followed by 38.97 at an angle of 30, and next 45 at an angle of minus 30, and then 38.97 at an angle of minus 150, and then complete the rectangle. So this is 22.5 and minus 150 again. So this rectangle has been plotted here. So now you can just mark the points. So these are the two extreme points where the base of the tetrahedron is going to lie. So let me select a line of thickness 0.50, change the color to black. So this, if I retrace, I'll be getting the base of the tetrahedron. And similarly, this is the midpoint of the opposite line. So this is the view that I'm going to get with the tetrahedron. So this is the top view. I need to extend this now. So let me select this rectangular prism, select the edges that are visible to the observer and change that thickness to 0.50 mm. So select 0.50 and then change the thickness of the lines that we have constructed. So this is the rectangle that we have constructed, and the midpoint of this opposite edge marks one end of the or one corner of the tetrahedron, and these are the two other corners. So from this point, let me consider again a line of thickness 0.13. So from the point of intersection, because the axis is collinear, let me consider the height that is equal to 36.74, that is nearly 3.7 boxes in the isometric sheet. So this is 36.74. So now go for 0.50 and then simply join the axis points to these opposite edges like this, and then you get to complete the tetrahedron. So again, in the isometric projection, you have to be very careful not to highlight the visible edges, the invisible edges. So this is how the combination of the solid is going to look. Correct. So these are all the construction lines which can be trimmed later. So if we just show this tetrahedron in the square prism or rectangular prism, that is sufficient. So go for the angle between. So this is 30 degrees and this is 30 degrees. So this is in the actual scale. So now select the entire combination of the solids and then reduce the scale to 0.816. So this is a very important step. So go for the scale option, change the scale to 0.816, the original dimension, and ensure the copy is off, and then place it at the same point. So you get the actual isometric view of the combination of the solids. And also let me use the split option here. I'll be considering this entire line. I'll split it at this point and also at this point. Correct. So now you can just see that this is a separate entity. So let me use the split option again. So select this entire line and this point of intersection. So change the thickness of this line of the rectangle prism, which is not visible to us. So make it a thin line. So this is the actual isometric view of the solids. So if you just go for the smart dimension, you can just see that the dimension has been changed. So the original dimension was 20 as per the true scale, but as per the ISO scale, it is equal to 20 into 0.816, which is equal to 16.32. So what we can do is just unlock this and change it to 20. Go for the annotation and enter ISO, indicating that this is equal to ISO 20. That means two boxes in the isometric sheet. Similarly, the isometric dimensions of the other parameters like the width and the length can also be shown. So this is 65.28. Unlock and change the dimension to 80. So this is ISO 80 and this is 48.96. Okay, so just change it to 60. So this is ISO 60. So the actual dimension was 60, but 60 into 0.816 changed it to the existing dimension. So whenever you're measuring, it is going to show you the true dimension and not the isometric dimension. So that is what I wanted to explain here. So select this, copy and paste it wherever you're showing the dimensions. So this is ISO 80. So this is how you can complete the isometric projection of this combination of the solids, where we have got a tetrahedron and a rectangular prism. And the two important conditions are the axis of the tetrahedron and the axis of the rectangular prism are collinear, and also one of its edges of both the solids. So this edge and this edge are parallel to the vertical plane. And this is the orthographic projection and this is the isometric projection. So with this, we complete the construction of the isometric projection of the combination of rectangular prism and the tetrahedron. Thank you all for watching.